Hello everyone, this video is for standard 8. In this video we'll solve exercise 3b of chapter 3 squares and square roots. Let's begin with the first question. First question says give reasons to show that none of the given numbers below is a perfect square. Yes, remember that I've already told you that the numbers ending with 2, 3, 7, 8 are not perfect square. Okay, if the ones place of the any number is occupied by these three four digits, then the number is not a whole perfect square. Also, if the number is ending in an odd number of zeros, suppose a number contains one zero at the end, or three zeros at the end, or five zeros at the end, then the number is not a perfect number, perfect square. Okay, so let's begin. So according to this, the first one contains two at its for ones place, so it's not a perfect square. Second number, as the number contains one zero at the rightmost place of it, or ones place of it, so it is not a perfect square. Okay, 2 3, I'm writing the numbers for your help. Okay, and as this question contains 3 at its ones place, so it is not a perfect square. Next, as you know that, as we you can write for question number 6, that as we know that number ending in an odd number of zeros is not a perfect square, and it contains three zeros at its end, so it is not a perfect square. For this you can write that as we know that numbers ending in 7 is are not a perfect square, so the given number is not a perfect square. For this question you can write that as we know that this number is ending in odd number of zeros, it contains five zeros. Okay, so as the number is containing five zeros, so the given number is not a perfect square. For last one, sixth, as as it is fourth one, not last. For this question you can write that as we know that the number is ending with 8, so the number is not a perfect square. That's it. Okay, remember this rule. These four digits you have to remember, and apart from it, if the number contains odd number of zeros at its rightmost place. Let's see the next question. Question number 2. Okay, let's just have a glimpse of the solutions. Okay, have a glimpse. This is 1. Okay, this is 2. This is the solution of 3. This is the solution of 4. Fifth solution, sixth one, seventh one. That's it. Okay, let's come to the next question. Which of the following squares are of even numbers? Okay, which of the following are squares of even number? You know that the square of an even number is even. Even square is even. Okay, always remember this rule, and then you will be able to find solve this question. This number is an even number, so this is the square of an even number. This is not an even number, so this is not the square of an even number. This is an even number, so it is the square of an even number. This one is also an even number, so this is the square of an even number. This is an odd number, so this is not a square of an even number. Okay, so out of these four questions, we have just these three as the square of even numbers. Okay, just see, have a look of the solution of this question. Pause and read if you have any problem in the solution. And let's see the question number 3. Which of the following are square of an odd numbers? Yes, as we saw that the square of an even number is even, so also remember that square of odd number is odd number. Okay, so if the given number is an odd number, then it is a square of an odd number. Okay, so let's see which of the following are odd numbers. The first one is an even number, so it is not the square of an odd number. This is odd number, so it is the square of an odd number. as the given number is the even number, so it is not the square of an odd number. As the given number is an odd number, so this is the square of odd number. As the given number for the this one, as the given number is the square of as the given number is an odd number, so it is the square of an odd number. Clear? Just have a look of the solution. So let's come to the next question. Question number 4. In this question, what you have to do, without adding, find the sum. uh, it has also been explained in the previous videos. You know that sum of first in odd numbers is n square. Sum of first in odd numbers, and also remember they must be consecutive. Okay, they must be consecutive odd numbers, like 1, and after 1, the next odd number is 3, then 5, then 7, then 9, then 11, then 13. Okay, just remember this one. Okay, so if we want to find their sum without adding, we just need to calculate these numbers, the number of these numbers. Okay, there are 7 numbers. Okay, you can count it yourself: 1 2 3 4 5 6. 1 2 3 4 5 6 and 7. So the sum is the square of 7. Okay, similarly you have to do the next questions. Okay, these two questions also you have to do yourself. You just need to count the number of numbers which are written here, and then suppose 1 2 3 4 5 6 7 8 9 and 10. Okay, if it is 10, then it would be the square of 10. Okay, just have a look of this solution. Let's come to the next question. Question number 5. Express 81 as the sum of 9 odd numbers. As the previous question, this question also will be solved by you in the same way. Suppose 89 is the, we have to say express it in as the sum of 9 numbers. So we just need to keep writing consecutive odd numbers as it has been done here. Okay, consecutive odd numbers written, consecutive 9 odd numbers has been written, and it has become the sum, and that is it has become the it has become 81. Okay, let's come to the next question. Express 100 as the sum of 10 odd numbers. The questions have been written 2 times. Okay, in the same way you have to do, you just have to write consecutive 10 odd numbers starting from 1. Okay, and you'll be able to solve it as it has been done here. Keep writing the consecutive odd numbers starting from 1. That would be the answer. Yes, the next and important question. Write a Pythagorean triplet whose smallest number is 6. Yes, for this I had told you a formula, which is this. Okay, out of these all, that is 2m, m square minus 1, m square plus 1, the smallest one is what? 2m. If the smallest one is 6, then the 6 would be equated to 2m. Then you need to find the value of m as it has been done. 2m equals 6. So m, as you know that 2m means what? 2m means 2 is multiplied by m. Okay, so as you know that multiplication changes to division when it changes its side, so it equals to 6 divided by 3, sorry 2, which is equal to 3. So the smallest the value of m is 3. Now depending upon this and using this formula, you can find the Pythagorean triplet as it has been done here. M square minus 1 would be calculated in this m square plus 1. The value of m is 3, the value of m square is 9, and then m square minus 1, m square plus 1, and then you are having the Pythagorean triplet. Clear? In the same way, you need to solve the rest questions of this. Okay, The rest questions are, the smallest numbers are given, that is 14, 16 and 20 has been given, and you have to solve it yourself. You just have to equate 14, 16 and 20 to 2m, find the values of m, and then find the value of m square minus 1 and m square plus 1. Then you will be having the Pythagorean triplet. Just have a look of the solution of the next questions. If you don't understand, just pause and read. Okay. So let's come to the question number 7. Yeah, this is very simple. This formula has been introduced to you, that difference of square of consecutive two numbers is the sum of the number, that is n plus 1 square minus n square is equal to n plus 1 plus n. Okay, it means that the difference of square of the consecutive numbers is equal to the sum of the number. Using this formula, you have to solve this question. You just need to, in a way, add the numbers. Okay, that is, if 38 square and 37 square is there, you need to find the sum of these two numbers here. And the same way you have to do all the questions of this segment. Just have a look of the solutions, do it in your copy. Let's come to question number 8. Using the formula, a plus b whole square equals a square plus 2ab plus b square, you have to evaluate these three numbers. This is very easy. It has been done in the examples also and explained in the previous videos also. For this, you just need to express 310. Let's take the first question, that is 310. You just need to express this 310 in this form, okay, in the form of a plus b whole square. And using the formula, you just have to put the value of a square plus 2ab and b square. Okay, and then substitute the values. At the place of a, you have to put 300. At the place of 2ab, you have to put 310. Okay, and at the place of b, you just need to write this. And then using the Brodmann theorem, that is first bracket and then the rest of the things, you need to solve this question. Okay, now have a glimpse of this solution of the rest questions. Okay, now next question, we need to solve this now. Using the formula, a minus b whole square equals a square minus 2ab plus b square, we have to solve this. We have to evaluate these things. Now in the previous question we were using a plus b whole square formula, and this question we are using a minus b whole square formula. So we just need to express 196 in the form of a minus b whole square. 196 can be expressed as 200 minus 4. Okay, and then using the formula, this formula, taking a as 200 and b as 4, we need to solve this. We need to expand it, find the square of 4, then 2ab, then you will have the solution of it. Fine. In the same way, you need to solve the rest questions of it also. Now question number 10, evaluate. Now we are done with a minus b whole square, a plus b whole square, and now next formula that we have to do is a square minus b square. I have told this formula also to you people. A square minus b square equals what? A plus b multiplied by a minus b. Okay, chalo. Here 69 can be expressed as 70 minus 1 and 71 can be expressed as 70 plus 1. Now it is in the form of this. You can relate it to this. Okay, now as you know that a plus b into a minus b gives a square minus b square, so you just need to find the square of these as it has been done here. and you are with the answer now. In the same way, you have to do second question, that is 94 multiplied by 106 yourself. Let's come to the next question, question number 11. Using the previous formula only, that is a square minus b square, a plus b whole square, a minus b whole square equals a square minus b square. You have to solve this. 88 can be expressed in the terms of 90 minus 2, and 92 can be expressed in terms of 90 plus 2. You have to do it and you will have the answer. Use never forget to use board mass, that is going to be very helpful in this. Okay, then you have the next question, 78 multiplied by 82. In the same way, you have to expand them and then write in the form of squares using the formula a plus b into a minus b equals a square minus b square. You have to solve this. Okay, now next question, question number 12, second last question of this chapter. The square of an even number is what? Square of an even number is even number. I've told you. Square of an odd number is odd number. The square of a proper fraction is lesser. Remember, lesser than the given fraction, because if you take the example of 1 by 2, which is a proper fraction, the square of it would be what? 1 by 4, which is lesser than 1 by 2. Okay, now n square, the sum of first n odd natural numbers. Odd. Okay, there will be odd. So now have a look of the solution of this question. Sorry. Question 13th number. Write T for true and F for false for each of the statements given below. Let's come to the first question. The number of digits in a perfect square is even. The number of digits in the perfect square is even. No. How can it be? Let's take the example of 100, which is a perfect square. 100 is the square of 10. But the number of digits in this is not even, is odd, which is 3. 3 is the number of digits in this 100. So this first statement is false. Now let's come to the next question. The square of a prime number is prime. The square of a prime number is prime. This is also false. 3 is a prime number. Always remember, 3 is a prime number and 2 is also a prime number. Prime number means what? Prime numbers means it will have just two factors, that is 1 and the number itself. It will not have any other factor. So the given statement is false. The given statement that the square of a prime number is prime is false, because 3 is a prime number and its square is 9, which is not a prime number. This is always true, that square of a prime number will never be a prime number. The difference of two perfect squares is a perfect square. Question number 3. Difference of difference of two perfect squares is a perfect square. Let's see. Let's take the example of 4 and 9, which are perfect square. Their sum is 13, which is not a perfect square. Sorry to say, but the sum of two perfect squares it was. The sum of two perfect squares is a perfect square, which is false. Sum of two perfect squares is not a perfect square. If we take other examples also, suppose if we take 4 and 16, which is 20, which is not a perfect square. So it's clear from there. The difference of two perfect squares is a perfect square. Let's take the example of 4 and 9. the difference of them, that is 9 minus 4 is what? 5. Is it a perfect square? No, this is not a perfect square. So the difference of two perfect squares is not a perfect square. Now next question, the product of two perfect squares is a perfect square. Yes, let's take the example of 4 and 9 only. 4, which is a perfect square, multiplied by 9, which is a perfect square, gives 36, which is also a perfect square. So it's true. Okay, the product of two perfect squares is a perfect square. Okay, so have a look of the solutions. Okay, examples have been given in each. That's it. Okay, and the chapter is over. Solve the questions of this chapter yourself in your copy. Okay, thank you.